Sorry about that. But again, you need to know that the first one given to you, whether it be the F1 or the G1, that's the pre-image. That's where you're starting. The second one, where you're looking at plugging in a piece and churning it out, that's the after the move, the image. You gotta know that. Yesterday, if you were with me, the first one was the F1. And the second one, where you're doing the work, was the G of X. Hopefully, I don't know, maybe one person's listening. Today, I mixed it up. So you're seeing, this is the first one. So technically, what you're doing is graphing that first one. I'm hoping at this point, I taught you enough how to graph. When you're graphing that blue one, that positive one, that's your starting point on this up and down y-axis. That number in front of x, that is your slope. Hopefully I've taught you enough. If it's a fraction, woohoo! Don't gotta put it over no one. If it's a whole number, gotta put it over one to get rise and run. But from there, over 3, up 1. Be able to graph. Stair step the left way, opposite. Left one, down one, left one, down one. Even though you're doing opposite, that's still positive 1/3 slope. And then draw your line. And then label it. And then tell me, that's the starting one. And then I'm going to say, what's going on? For this shift, really what's going on? That little -4 number tells you that the new one's going to be shoved 4 boxes down the y-axis. So here we go. 1, 2, 3, 4. That's where the new one's going to go after the vertical shift going down. And I know it's going down because that's -4. And then it's going to be that same slope. Over 1, up 3. Over 1, up 3. Left 1 or left 3, down 1. So right there, without really even doing math, that's showing what you need to know. The first one. The second one moved down 4. Got shifted down 4. But then I'm going to say, what is the equation of that new one? You need to either look at your graph and tell me what the equation of that new one is just by looking at that graph. I can see that it has the same slope. These always have the same slope, 1/3. But it's got a new y-intercept, -3. So you get that by either looking at your slope and your new y-intercept after you've moved it down, or if they ask you to plug it in, you could do it the high-tech way. You could find that G of X1 by taking part of the blue one.
Excuse me?
Yes, let me finish this and I'll take questions.
Of course.
I'm going to plug that in right there. In that math right there, that's really the high-tech way of finding out what that G line is right there. All right, can you see this?
Yeah.
How long were you going to let me keep talking? Yeah. Oh, you know what? You guys in Zoomland, you got to interrupt me right away. I mean, don't have me. I could have talked for like 20 minutes there. So yeah, I will never be offended. You people in Zoomland, if you're like, man, I have no idea what you're talking about, Marshall. Are you writing? Say, Marshall, I can't see. Because that kind of blew it for you guys. I explained this whole problem into nothingness for you guys. All right, who was that who told me? All right, Quinn, let's give you extra credit. All those other people in Zoomland, I don't know what they're doing. Just looking at their cell phones or something. I don't know. But again, that is a linear transformation. For today, man, I was hoping you could have saw that, Quinn. I switched it. I made the first one the G1 today. And the F1, which I could see a mistake right here. That's not G of X. Let's fix that. I switched it today to have the F of X be the new one. So, let me work on my labels here. All right, anyone out there live or in Zoomland, can I explain this topic any better? Start, new one. The starting one, the new one goes down this many boxes. This number doesn't give you the y-intercept of the new one, but it gives you the tools mathematically to find the y-intercept of the new one, either by moving the original one down and seeing the new y-intercept, or plugging it in algebraically to get that new y-intercept. Stop right there. Anyone even listening?
Question?
Yes, question.
So, with the next one, that's to the right a little bit, the triangle? That's the X one?
Yeah, what about it?
I'm a little.
I'm going to show you right now. Are you ready?
Yeah.
All right. Hopefully people out there or in front of me knew that first topic underneath the shade, the linear transformation. Cover that up because people just get overwhelmed with stuff. I don't want to overwhelm you. All right, the next one is similar triangles. Got to know it. I'm having you solve for X. You set up the first ratio, but this is one of those trippy ones where the similar triangle is part of the Big Daddy triangle. You see that? So you got a little bitty in here, and you got Big Daddy. So those are the parts. And you need to see that for this red triangle, I got X, 4, 7. But for the big hidden daddy triangle, those lengths trip some people out. This length is 15. This length down here is really 20. And I got that by adding 60 and 4. That's how I know that real bottom length of the entire big bad boy. And then the other one. And then let me just check something here. Well, hold on one second. I need to make a tiny little change right here. Hold on one second. I think I made a little arithmetic mistake. Yeah, it's got to be 28 right there. All right, with that 28 and that 7 right there, I need you guys to see that that big length is really 35. All right, I'm going to stop right there, field some questions. What's going on? Questions? Yes, Edwin.
Well, then X inside of the triangle instead of number.
That's the piece I'm going to try to show you how to find. All right, to find that missing piece right there. Let me just explain this, and then I'll take questions. So to find this missing piece, I need you to see that these are two similar triangles. I have a bitty triangle inside that has a base of 4, a hypotenuse of 7, and this little side piece of X. The Big Daddy triangle, I didn't give you really all the lengths, but I gave you all the tools and the numbers to find all those lengths. And now what you're doing is, to find that X, setting up the first ratio, and maybe, keep it easy. The little side over the base of the little. And then make the big daddy numbers match up. But no, you had to find that 20 and 35 yourself. We're not writing those numbers on paper. We need you to be smart and see that, the whole entire Big Daddy triangle really has a base of 20 and a hypotenuse of 35. I'm giving you the side piece. So if you're keeping that X over 4 accurate, you got to go 15, not over 16, but 15 over 20. All right, are you seeing that out there in Zoom land?
Yeah.
All right, sweet. And then you crisscross multiply. And that algebraically gives you the answer that a lot of people, they don't really need to do the algebra to solve for X. They know what it is. But we want you to show the algebra. 20 times X, 20. 4 times 15 gives you 60. Right there, show me Now you divide. Don't cross multiply and try to divide all in one step. That's going to trip you out. Cross multiply first and get the equation checked. I got it. Now solve it. Now divide both sides by 20. Don't jump the gun and try to cross multiply and divide at the same time. That's tripping people out to do that. So that value is 3. Are you seeing that out there in Zoom land?
Yeah.
It makes sense. Check it out. 5 times 3 times 5, 15. 4 times 5, the big daddy length, 20. 7 times 5, the big daddy hypotenuse, 35. Right? Okay, and then the last one. I gotta have you know those triangles. Oh, the sucky triangles. So again, these are the big ones. This first one shows a pure sandwich, an angle sandwich between a side. Oh, no, a side sandwich between an angle and an angle. Angle, side, angle. Memorize these. The other one is 2 angles and a side. There's no side between those angles. That is not angle, angle, side. This is angle, angle, side. This is angle, angle, side. And then for sure, both those are congruent. Get full credit. Put that symbol or write it. The other one, AAA. Always similar. Not always congruent, but always similar. And I got one more sandwich right here. Those are the big ones. Commit those to your memory. Those are the ones you'll see the most. And then the last one is a little twist on that. I'm giving you the theorem. I'm telling you, for this one, it has to have an angle, a side, and a side. You put the mark in the right place to show angle, side, side. So you don't want to trip out and put an angle right here, because that doesn't show angle, side, side. That would be angle, side, angle. Why would you put that little angle mark right there? Don't do that. You don't want to put that side right here. If you did that, that ain't AS. That's ASA. No, that's SAS. Don't put the mark there. So you need to know what AS is, and you need to know where to put the mark. Not the right. That's the only place I can put that mark for that to be AS. That make sense? All right. Okay, I want you, best you can, just know whatever you say is going to give you full credit. I will help you a little bit best I can, but I want to see what you really know without any pressure. Whatever you say will get you full credit. I want you to take this slide right here, paste it onto your own. If you're in class, they all have their devices, or they're using my computers. Those of you at home, I want you to go to slide 53. That's the one you're going to click on, and then right-click copy, and then go to your slide and right-click paste. That's how you get it on your slide. And then you could do work on paper and put a picture on there, or you could do all the work using the Google Slide tools, like a text box to type your work, or a line to graph your lines. And I could help you with all these little tricks. I mean, there's a way to show your work on here. You can make your lines thick. You could fully do it legit with practice. You might as well practice. I mean, that's something you put on your resume, that you can use Google Slide tools. But try it. And then, yeah, for sure.
Awesome.
Put a picture on your slide. We are in about 15 minutes. We're going to start hearing what you guys say, ready or not. So I'll give you about 15 minutes. Try as much as you can. Don't feel like you need to do it all. Technically, you have the skills to do them all. I will help you best I can. And then just know, no matter what you say when I call on you and show what you put on your slide, you're going to get full credit. My people in class, I'll give them the option of putting their work on the document camera to talk about. So they really don't have to do it on their slide, people with me, but they have that option. Does that make sense? Anyone? Questions for me? All right, careful on that slope one though. That slope, that's a negative slope. Going over one down to you, so don't be drawn on line like that. All right. I help you. So maybe since you have time, you can put a picture of this on the slide. Yep. Or you have to help everybody. But no matter what, I don't want you to see your picture on your slide. You can type about what you're going to say. And then maybe when you're done with that, help people. I'll give you a credit to help. Question out there? It's on my class Google Slides. I'll put that link in the chat. Once you get to it once, it will always be in your quick links. Here it is. I disabled the chat earlier because I don't want people typing. I don't have time to look at your chats. You got to either talk to me or email me. I'm not sure. You got to talk to me out loud. I put that in the chat.
Thank you.
You're welcome. You're welcome. Yes, sir. Wait, what was the question?
I just had a question for you. Yeah, this one?
Yes.
So, X by 4.
No, well, you wouldn't want to use just that 16-piece sand shoe because that doesn't represent the whole bottom of that big triangle. That would just be like a little piece of it. I took that 16 that I'm giving you for that piece, and I'm taking that 4 for the other, and you know it's obviously not drawn to scale, but that 16 and that 4, that gives me the entire bottom length of 20. You see that?
Yeah.
You sure?
Yeah, thanks.
All right, you're welcome. You want to earn some extra credit, Anshu? I knew you would. You're smart. All right. Looking at this one, do you see it? The one on my screen, do you see it? This is the one that people are doing right now. Do you see the parts of the little red triangle? All right, now I'm showing you the Big Daddy triangle. What are the lengths of the entire big triangle? Yep. Yeah, you gotta add them because you gotta get that length. I'm trying to fool you into thinking you're gonna use that 16 and 12 in the ratio. You're gonna use them to add up to get those lengths, but you're not using them in the ratio.
Yeah.
So what are those gonna give you if you add those up and you help my classmates out, give you extra credit?
24.
So this is gonna be 24, yes sir. The bottom length would be, right, and then above and beyond to help these people, can you give me a ratio based on all those numbers to solve for x?
So, X goes.
So that's the pattern you're establishing. You're doing the side of the little over the bottom of the little. Now you got to stay consistent with the big pieces.
So,
And then you remember how to crisscross multiply that and solve, right?
yeah.
All right, go for it. I know you can do it. Good job, Andrew. Thank you for communicating with me. Anyone out here? Yeah, Miss Elizabeth? I got that by either graphing the first one in blue and then moving it down the y-axis 4 boxes because it's telling me to, and then using my eyeball to get that new y-intercept. My eyeball looks and sees that that y-intercept is -3 right there, Elizabeth. Or the real algebraic way is to realize that, you know, if g of x equals 1/3 x plus 1, I can take that piece and plug it into this g of x spot right here. And when I do, I'm circling right here. Do you see this, what I'm circling right here, Elizabeth? That is the g of x chunk plugged into the f of x one. And then that 1 and that -4 that was originally there, that gives me the -3 algebraically. Sure. All right, you want to earn some extra credit, Elizabeth?
Yeah.
All right. For this one right here, the one I'm having my classmates do, how about right off the bat, do you know what the new y-intercept for the F line would be just by looking at this? %. Yep, it's going to be 4. Because you're looking and seeing that just before you even do any math, because you're smart. If you put this in here, that -1/2 x, that's never going to change. But that 1 that came from that original g equation with that +3, that's part of the for this one, the f transformation equation. That's going to add to give you 4 right there. You saw that. Or if you graph the original one at +1 and follow that slope over 1 or over 2 down 1, I bet a lot of people are maybe graphing this incorrectly. Graphing -1/2 always gets people. But when you graph that and move that 3 boxes up the y-axis like that shift number is telling you, it ends up right there going through 4 on the y-axis with that same slope. What do you think about that, Elizabeth? All right, good job, lady. That is a big, big concept right there. And that 3 moving up, it doesn't give you the new G lines equations y-intercept. It just gives you the tools to get it with either your eyeball, which most people, you know, they'll just use their eyeball, trust their eyeball. That's going through 4. Y-intercept's 4. My eyeball says 4 right there, 4, eyeball. Or you could do the high-tech algebra. Take that for this one. And again, I'm mislabeling it. I would be missing points for that. This ain't the g of x1. I gotta be careful. I'm trying to fool myself. I'm trying to fool you guys. This is the f of x1. Trying to be fancy and fooling myself. All right, a couple minutes away. What can I do? Help anyone look like they're math teams? Okay, anyway, anybody? I'm gonna give you a few minutes to start the show. I'm gonna let people in class use the document camera if they want. The rest of you, I'm looking on your slides. Try to have some work on there or a picture of your work. Is there anyone I could help out there in Zoom land? Let's just take a quick preview there. It looks like some people are getting it on their slides. All right, so people have started, so I'm happy about that. So maybe those of you done already, just kind of rehearse what you're going to say. Know what you're going to explain. You ready for me to ask a question? Ask me a question if you don't understand. I do expect you to know how to do all of these. So if you're confused really on all these, you're starting to fall behind us. What can I do to get you caught up with us? All right, let's do it. The people in front of me, they look like they're going to die, so we're going to get started. All right, Marco, are you out there? Marco, I'm doing this for attendance purposes too. Marco, are you out there? All right, Marco, I'm just going to mark you absent. I'm using this for attendance. This is like my roll call right here. So Marco not here? All right, mark you out. Let's keep going. Apologize for that mishap. I'm sorry, sir. All right, next, James. Are you out there, James? All right, can you tell me about what you've done so far? Oh, you know what? Thank you. Can you see that now? Can you see that? All right. Can you tell me about what you did on this slide, James?
How about this? Which one is the image? Which one was the image? Okay. Okay.
equal to you put x over 6 equal to what, Andrew? Are you up there? Alright, I guess I'll get back to you. Jade, are you in front of me? Did you put it on your slides or do you want to use my document camera?
It's on paper.
It's on paper? Alright. Ready? Anshu, we'll get back to you. People in Zoom land, can you see this pen that I just put in front of the document camera? Can you see that?
Yes, sir.
Alright, hallelujah. Ready, Jade? Alright, Jade did hers on paper. So I'm going to put hers on the screen. Let her talk about it. Alright, Jade, can you tell us about those triangles that you labeled right there?
The first one I got as side angle side.
Nice and done. Oh, are you sure? Oh, yeah. Good job. Side angle side. What about the next one?
I got angle side angle.
Good job. How about the third one?
Side side side.
And the fourth one?
Side angle side.
This one, are you sure this one's side angle side?
Yeah. Or side side angle.
Yeah, be careful. Yeah, this is definitely side angle or the ass one. If I wanted this to be side angle side, I for sure would have had that angle right here.
Okay.
You see that? But yeah, this is for sure the double SA. That one fools everybody, you know, they think it's SAS or ASA. And then right here you put where'd you put the mark on this one?
In the one with 2 lines.
What is this really showing you right here? Do you see? Oh yeah, angle side. Good job. All right, who's next? Let's keep going. Yes, question. The bottom right is SSA. You're welcome. All right, let's keep going. Harley, did you put yours on paper? Or?
Mine's on paper.
All right. Got another person in class. Let me see. Get this going. Yes, sir. All right, hold on. Harley, for your points. Harley, what did you do for the triangle one? Hold on one second. Can you guys see this?
Yeah.
All right, then hold on one second. Harley's explaining her middle one. What'd you do, Harley?
So I added the 2 numbers on the side for the Big Daddy one.
Yeah, got 18 and 24. Good.
And then I divided them. I took the numbers, the X and the 6, and then I took 12 and 18.
Good job. And then you multiply straight across or crisscross?
I crossed the crisscross.
Good job.
Cross multiplied and then divided it by 18 and I got
100% got 4 right there. Good job. Who was talking to me out there?
Frankie.
What's up, Frankie?
Just a quick question about the triangle. It's pretty much the same thing as what we've been doing. You just have to put the on the side and X to add to the 12.
I didn't really understand your question, but yeah, similar triangles, solving for X, setting them up and solving.
Okay.
All right. Okay, let's move on here. The people in front of me who look like they're gonna die, I'm so sorry. All right, next. Julie, are you out there, Julie?
Yeah.
Can you see your presentation right here?
Mm-hmm.
All right. Can you tell us what you did for your first one there?
Yeah, I put the G of X incorporate into the FMX equation, which is GMX, and because FMX equals negative 1 half x plus 1,
Cool.
and then you have to add that in.
Good job. Can you hear me, Joey?
Yeah.
For that problem, which one is that pre-image? Which one's the image?
The pre-image is GMX and image is FMX.
Good job. Good job. Yep. Excellent. I like it. That's such good work, lady. Beautiful work.
Thank you.
Juliana. Quinn, are you out there? Thank you. Next. All right, Quinn. All right. Can you just tell us about your triangles there, the congruent ones? I like it. What'd you do? I like it.
Outside and then
Okay, hold on.
just
All right. Yeah, I see a pure sandwich right there too. Good job. What about? Keep going.
keep going. We're gonna keep going. Okay. So I'm gonna put an X after that.
Good. Good job, Quinn. Excellent. All right, Sam, you out there? Zamara out there?
Yeah.
Right. Can you just tell us how about your triangles? What did you list for your triangles, Mark?
Which one?
The ones on the right, the ones that you label. The 3 big black letters, I see SAS is one of them. How did you get those answers? Can you tell me? Well, I see the first one you wrote SAS. I'm wondering how you got that. Well, that's correct. Can you tell me why that's correct? Why SAS matches that triangle set right there in the top left that you wrote SAS on? Can you tell me why? I mean, why did you write SAS? I mean, can you tell me that? Okay. I mean, yeah, that's what I'm looking for. I'm wanting you just to tell me in words, like, I mean, how do you know it's SAS right there? Or how about the next one? How about the one below it? That is really SSS, because you missed an S. For that bottom one underneath it, that's SSS. You know that one's SSS. All right, good job, Samara. We're gonna move on. Gia, are you out there?
Yes.
All right, sweet. Didn't want to mark the absent. Can you tell us how about, let's go back to those congruent triangles. I know those are a crushing low. How did you get your answers for those congruent triangles, Gia?
So for the first one, because if you like go on the other side, so when it gets to it, it's that side with the opposite photo, and then let's go down to, and then congruent, and then the last one is SSA or ASS.
Okay, and then for your bottom one, how come you put the marks where you did on that? Does that show AAS? Okay. Well, all right. Well, I'm looking, the way we're looking at your marks on your paper, it looks like you did it side angle side. So maybe you didn't put the mark in the right place. I wanted that to be, oh, you know what? It looks like, oh yeah, it looks like you did put the angle in the right spot. I take that back, Gia. Yeah, you have two angles and a side. That matches perfect, Gia. Take that back. Good job, lady. Elizabeth, are you out there? All right. Can you tell me what you did for the first one? Good job. And then let me just ask you this, that +3, do you know what that 3 number represents for this problem, Elizabeth? What it shows? What does that 3 represent for this problem? It's not the y-intercept of the new one, it's... All right, but do you see how that 3 is the amount of boxes the original line got moved up the y-axis? Do you see that? Yeah, that's a big concept. You graphed this perfect. You graphed the G1 through +1 on the y-axis, and the new one got moved up 3 boxes. Perfect. Going through 4. Good job, Elizabeth. All right, Diego, are you out there? Manuel, are you out there? Yeah. All right, Manuel. Do you want to do it on paper? Can you people in Zoom land, when I'm getting this going, can you see this screen right here? Can you see that? Sweet, thank you. All right, Manuel, can you talk about your triangle ones too? These ones at the top right, these congruent ones.
I saw the angle sandwich, so it was an SAS.
Perfect, saw the sandwich.
And then down angle side angle.
Another sandwich.
And then down 3 sides, so SSS.
Good.
And down was angle side. That was ass.
Good job. So I'm happy. Some people, you know, congruence, I don't teach it very well. Try my best. All right. Callan, are you out there? Callan. All right, I am using this for attendance purposes. Callan, you're not out there? Oh, that was close. Do you have something on your slide, Callan? Can you see this screen right here? All right, did you do one of these problems? Oh yeah, we're explaining these right here for points. Did you do anything? Did you do any work today? Callan, I'll just give you a 0. You're gonna have to do the flip grid later to get your points for that. And that's kind of respectful. If you were in my class, that would for sure be the misconduct. I'd have to have you stay after and document your behavior on cue, so it's documented forever. Super disrespectful. I don't know what you're doing. Diego, are you out there? And Callan, I'm gonna mark you absent until you get that done. Diego, are you out there? Diego? All right. Christy, are you out there? All right, lady. Good job. Did you put a picture of your work on there?
I remember that's
I like it. Can you talk about what you did right here, lady?
yeah, for the first one, I took the Genvex and put it Genvex equals -1 over 2x plus 3, and then I solved it in Genvex equals.
Let me ask you this. Did the slope change when I shipped it? Did it change?
No, the slope doesn't change.
No, slope doesn't change. What does change though?
The only thing that changes is the y-intercept.
Nice job, lady. Great. Good job, Christy. Proud of you. Your grade's lifting solid, lady. Frankie, are you out there? Frank? Thanks, Lula. Frank, you talk to me. This is for attendance. I'm taking attendance right now. Frank, are you out there? All right. Victoria, you're in front of me, right? You have on paper? All right. Almost done your troops. All right, can you explain the problem of your choice? Problem of your choice.
For the middle one, for 12, you do 12 plus 6 for 18.
Good.
And then 16 plus 8 for 24.
Good job.
And you do x over 6 equals 12 over 18, and then cross multiply.
This is beautiful, Victoria, because you're smart. Can you give me another ratio that I could use to solve for x that doesn't quite match that one, but would still give me the same answer?
You can do x over 8 and 12 over 24.
All right. Making my heart warm. I know I can't teach effectively to everybody, but if I'm teaching effectively to a few people, doing my job. I can't teach you 100%. All right. Who am I missing? Let's keep going. Sorry about that. Almost done. Almost kickback time. All right, Reggie, are you ready?
Yeah.
Is it on paper? I'll have you put it on your slide, right?
Yeah.
All right. Can you tell us, pick a problem of your choice?
Any problem?
Any problem?
Can I do the last one?
Yes, you can.
For the last one, to give the theorem AAS, I put the angle right next to the original angle between the
Good job.
angle and side.
Good job. What would be wrong, Reggie, if someone wanted to show AAS and put the angle like right here?
Yeah.
What would be wrong with that?
Well, because on the side would be between the two angles.
Yep, then that would show angle, side angle, right? Good job, Reggie. All right, almost done. Edwin, are you out there?
Yeah, I'm doing it like this, but I'm just doing one more problem.
Do you have anything on your slides?
No, I'm not doing it.
Okay, can you just tell me out loud anything that you've done so far?
So for the second one, I did x over 6, and then I did 12 over 18.
Okay, to really see if you're knowing your stuff, just like Victoria did, she gave me another ratio for that problem. Can you give me another ratio that would work for that problem, Emily?
16 over 8.
Yeah, you wouldn't want to do 16 over 8. How about instead of x over 6, what if you did 6 over x? What would the other fraction have to be? I think if you did 6 over x, you would have to compare 18 over 12 to get that one right. You're doing good though. We'll keep going. All right, White, are you up there, White?
Yeah.
All right. Let's end your week right here, White.
Okay.
We look at that proof that graphs can be done on regular line paper and legitly done. I've not seen many people graph on regular line paper and have it not turn out real ghetto. But Wyatt, you did good. You graphed. All right, can you tell us something about what you did? Pick a problem of your choice. Okay. Just because I want to see, can you give me another ratio that would work for that one?
Oh, sure. You can.
24.
Thank you. That's good. So you can do 20 over 20.
Good job, Wyatt. Zach, are you out there? Richard Angle, are you out there, Richard? All right. Adrian, are you out there? Is there anyone out there that doesn't want to be marked absent? Talk to me right now.
Yes.
Oh, I answered you. Yes, you did. You want to finish? All right.
So,
Yep. Beautiful work, Anshu, but because you're showing me that you're smart, I'm going to ask you a tough question. Are you ready? That ratio worked perfect. Can you give me another ratio that would still give me that same answer? 8 over x?
Yeah.
Would equal?
Okay. 8 over x equals 12.
Yeah, you're a stud. Good job, Anshu. Your week is done. Hey, no worries. You understand. Your week is done. You being smart, I'll cut you slack any day. Good job, dude. Is there anyone else out there in Zoom Man wants to be marked present? Because I'm doing this for roll, taking roll. And yes, Aiden. All right. Do you have it on your slide, Aiden? All right. So I'll just pull up this screen here. Can you just tell us anything that you've done so far, Aiden? Tell me something. Okay. Nice, perfect. What is the Aiden? What's the congruent symbol? Do you know that symbol I need you to write? Good job, Aiden. What about the other ones in that box? Good job. Good job. Good job, Aiden. Proud of you. Good job. All right. Anybody else? Our day, our week is technically done. We're right on the dot with that. All right. You people in Zoom land, go ahead and hold on to that word. I'm not going to expect anything. You people live, hold on to that word too. I'm not going to expect it. And then last call. Anyone else out there want to talk to me so I don't mark the absent? Give me your points, easy points. You all smart your classes. And then hopefully you're being motivated. All right. You guys have a super good, safe weekend. Remember, if your classmate can do these, you guys can do these. No one's smarter than anybody else. Good job, people. Have a good, safe weekend. All right, Wyatt, you people have a good weekend. Last call out there, Zoom people. What's that? Who am I talking to? Oh yeah, whoever talked to me today for sure is not absent. You can hold on to that. So Alex, you weren't able to present it? Oh, so you're gonna have to do the flip grid to get full credit then. So just, when that happens, say, Marshall, I want to show it. Or you know what? The next time we meet, if you want to show it in front of my class, I'll give you the full credit. If you want to. But yeah, if you're in class, you gotta let me know. I didn't get a chance to show. I kept asking anyone. Have a good weekend. All right, I'm gonna log off here. What's up? Question? No flip grid. If you guys talk today, no flip grid. Yeah, it's always gonna be that same private Flipgrid link. I'm always using that same link. So if you look, that same link is already on like 3 or 4 slides. Okay. All right. What's up? Yeah, you gotta go straight to 3rd period or 4th period.
Okay. So
Yeah, 4th period. We're out of here at 12 o'clock. We're out at 11:50 today.
is there any break or anything?
Break is after this next period.
Oh,
It's kind of a weird schedule.
So it's passing right now?
What's that?
So it's passing right now?
Yeah, you got like 5 minutes.
Okay. See ya.
Yeah, have a good weekend. Yeah. How's it going?
Oh, I'm not there.
All right, just sit in a spot right now, and I'll put you on there. Are you not a B group person?
No, it's A group today.
That's not this period, right?
Yeah, but that's
Yeah, this is the A group, right?
Yeah.
So that picture, that's the A group. That's the A group. Is anyone in here on this? Is this the A group? Are you on here? I'll see. I'll put you in somewhere on here, I promise. I need to take care of this. The grades on the wall are brand new if you want to see.
You think it's okay if I can go to the library?
You need to be in class. I'll mark you absent if you go.
Oh no, it's just the computer shop has a problem.
Well, I have computer for you. If you want to run it, I'd rather you be here. I don't want you missing class. Let me get this ready. It wasn't quite ready. If you could check out those grades while you're waiting, maybe. And then I'll try to get you in the right seat there. All right, let's get you in the right seats and let me clean up my mess. All right, Gio here today, Gio. Is Michaela here?
She's here.
Not in her seat. Is Julian here? Is Josh Green? Sweet. So Josh, I have you at the front of row 3. Right there, yeah. Is Elijah? So you're right. You're in the first. Who in here? Gabriel Hernandez? So Gabriel, you're the second seat in row 4. Kayla is the first seat in row 1. You guys will get it. You'll be pro at it. I need you for sure to be able to figure out my seating chart. So it goes row 1, 2, 3, 4. So you are right here. And then who are you again? What's your last name? 101? All right, welcome. So Juan, I'm going to put you at the second seat in row number 1. All right, grades on the wall are brand new. For people with me or on Zoom, if you look at those grades online, those are accurate, those are good. Let me fix up this mess here a little bit, and then we'll get started with our day. We are going to be doing little presentations on your Google Slides. So hopefully people have their devices today. Anyone out there in Zoom land, can you hear me? Thank you. Let me clean up this mess. I'll make sure next period I don't have to do this fiasco. All right, can you people see my screen there?
Yeah, but
All right, let me give you the first little State of the Union address for my class, just to let you guys know where we stand. Again, everything on the shared document, the last 3 grades on Q you will see. I graded the classwork for the 22nd. There is a little video key that I'd like you to watch. It's super short, I think it's like 2 minutes. If you show me the work for that day and you write down those 3 words, I'll give you a 10 out of 10 on that classwork for the 22nd. There's an example of some people who did that work that we did yesterday in class, periods 2, 4, 6. Also on there, if you want a little chance to get that 10 points for doing the little oral work, we explain in class, some of the things I've been teaching this quarter. People did that, it took them 10 seconds, got their 10 points. If you didn't do it, you got marked absent. And then, of course, to get those points, you're going to be forced to do the little private flip grid of your face, which no one's going to see. We also did yesterday, we reported out on the step I was trying to teach people. People did that in class, took them 10 seconds, got marked present. People who didn't talk in class got a 0, got marked absent. People who worry about their grade, you could do a flip grid for that. But again, every grade on Q that you see, there's going to be something on this master Google slide for you to see to make up this quarter grades to be made up for full credit. So if you don't have 100%, that is all on you this quarter. Your grade that you see on Q is your choice. I'm not making you choose any other grade other than what you want to choose. If you look at your grade and it's not 100, and you know your teacher is giving you the right to make up everything for 100%, that grade is all yours. It's not me giving it to you, it's you giving it to yourself. So from here on out, quarter 4, your grade in my class is what you want. If you want 100, I'll help you get that 100. Everything can be made up for full credit. If you're happy with your grade as it is, go for it. You have the right as an American to fail. I cannot force you to do nothing. If you're happy with that grade, that's your right. I can't make you do anything. But if you're not happy with your grade and you know you can make up everything for full credit, let me help you get that 100%. So when you go into the big benchmark in June, you'll have a little cushion with your grade. Anyone even listening to me out there? All right. What we're doing today is I'm going to show this set right here. The people in class I gave it to on paper. And then what I'm going to have them do is you're going to go to your Google Slides and you're going to do a set your own. And then you're going to explain it loud to the class. I'm doing that for attendance purposes and for a grade. So just make sure when I show you the first one, and again, because I'm zooming, I hate this transfer back and forth. But again, today I'm going to show you guys this first set, and then I'm going to have you copy slide 53 onto your own by copying and pasting. And then I'm going to have you do the work for it and talk about it out loud here in about 15-20 minutes for attendance purposes and for points purposes. All right, so here we go. Can you guys see the screen right here? Sweet. Okay, what I need you guys to know so far is all 3 main concepts for this quarter. Yesterday, I taught you how to do linear transformations. If you're not worried about your grade, at least pay attention so when people hear you talk, they don't think you're foolish. Because, who cares about your grades? You care about what people think of you, right? And you don't want people hearing you, what? There's tripping. So if you're confused, have me explain it to you. You don't want people thinking you're funny. Because again, I know my 26 years of teaching grades don't motivate really a lot of people. But man, peer pressure does all you. All right, so here you go. If you don't want to look foolish, pay attention. This first one I'm giving you, this is the pre-image. Whatever's listed first is going to be what's first. Yesterday, if you were with me, I made the f of x be the first one and the g one be after the move. But today, because you're smart, I mixed it up a little bit. I put that g1 as the original one and the F1 after the move. And if you're listening to me out there, what I need you to know for these problems, you're starting with the first one and no one had to graph it. Hopefully you know at this point to graph this blue G line. You start at 1 on the y-axis, this plain number right there. And then from there, because that rate of change is already a fraction, you don't gotta be putting it over no 1. It's a fraction already. That gives you the run and rise already. From that 1 point, right 3, up 1. Right 3, up 1. Stair step the opposite way. Down 1, left 3, or left 3, down 1. Still on the same line. Don't mess up. I saw a lot of people yesterday, they were going right 3, up 1, right 3, up 1, down 1, left 3, down 1, left 3, and then all of a sudden they're like, down 1, left 2, jacked up. Be precise, troops. I could see that if you're following the pattern all the way and all of a sudden jacking it up. I can see that. That line is the line f or g of x, the 1/3 x plus 1. I'm telling you, you've got to know how to graph in this class. And then really what I taught you was this. That's the original because it's first. If you want to find a pencil, look around, dude. Don't just sit there all period long doing nothing. Look around, dude. Take control of your life. All right, the second one is going to be moved down 4 boxes. How do I know this is being moved down 4 boxes? Because it says go down -4. So technically another way of doing this is drafting the first one, knowing that it's going to move down the y-axis 4 boxes. 1, 2, 3, 4, right here. That's where the new line is going to be going through, right there through the y-axis. And from there, same slope. Over 3, up 1, over 3, up 1. Stair step the opposite way. So there's the first line in blue. There's the second one in red. Then moved down 4 boxes, matching that shift number. You could do it that way, and then use your eyeball to write the equation of that red line after you've moved it down 4 boxes. That new line has the same slope of 1/3, but my eyeball looks, when I moved it down 4 boxes, it's slicing through -3 on the y-axis. So you could do it that way. Graph the first one. Look at the shift. Move it up or down. Graph the second one and write the equation for it. Or you could get that equation algebraically. You know what? I mislabeled that. This is the F1. Watch your labels. That red one's the F1. You label that. That's the image. Or algebraically, you can find that by doing this. To find that red line, I could take part of that blue line's equation and put it into that main equation right there where I'm taking away 4. And what happens is that is the algebraic way to get that y-intercept, not the eyeball way. The eyeball way is to shift it down. Use your eyeball to see what the y-intercept is. The algebraic way is to plug in this into g of x, since these are equal. Have your +1 from this, and your -4 mathematically give you the new line's y-intercept. Stop right there. Can't explain any better. Sorry, well, you could run to the office. They might be good. Sorry about that. Questions about this first one? Yes, sir.
The slope never changes, right?
Slope never changes. They're both over 3, up 1, over 3, up 1. The only thing that changes is the position, either up or down. If this would have been +4, would have started here. New one would have went right here. A new y-intercept of 1, 2, 3, 4, 5, which I could have also got by plugging that in if that would have been +4. Kind of
So the lines are always parallel.
The lines are always parallel. The only thing moving is its position either up or down. And the only thing changing when you're moving stuff up or down is where it's slicing through the y-intercept number. Yeah.
So the y-intercept is something that moves around everything else.
Yeah, the y-intercept is the only thing that shifts either up or down. And you always matches this number. But like I said, people get confused and think, oh, the new line after I've moved it down is 1/3 x minus 4. I'm like, nope, that's the shift number. That doesn't tell you this y-intercept number. That you got to look yourself, or you got to plug in and do math. Good question. See how smart you people are. All right, next one. Inline. Here we go. The hidden little triangle and the big daddy triangle one. Oh no, look at this. So for this one, you need to first identify the parts. This is the little bitty triangle, the red one, but the sides of the big daddy one, that's the question. And hopefully you can see that. This has a little red triangle, the little baby one, inside the entire big overall big daddy blue one. Hopefully you're seeing it. But now you got to know the lengths. The lengths of that little baby one, x4, 7. But the big daddy one, it ain't 16 in this, it's 20. So you need to do a little bit of math yourself to find really the length of that big daddy one, which means the hypotenuse. And if you can make this change on your paper, because I made a little mistake, that should be 28. The big daddy hypotenuse isn't 28 or 7, it's 35, and obviously I didn't draw just the scale. All right, stop right there. That concept right there, confusion, before I put it into play. All right, and then when you set it up, I'm going to go from within. I'm going to go x over 4. And then hopefully you guys are, because you're smart, you're going to see that if I'm doing the side of the little baby over the base of the little baby, I got to be consistent and divide that by equal to the side of the big daddy, but over the bottom piece of the big daddy. I'm not using 16. I'm not using 4. I'm using 15 over 20. Do you see that out there, sports fan? You don't want to put 16 here. You don't want to put 4 here. You don't want to do any other pattern. You could have done other patterns. Yes, sir. Question.
So are we just adding the sides of the big triangle, the small, together?
Yep, because if I'm asking you what this entire length is right here, and I give you 2 numbers that show, you got to be able to understand those numbers added up give me this full length. And these, if I give you 2 numbers, this entire length, which is the hypotenuse of the big triangle, you got to add those up to get that length. We're not going to tell you. You want to figure it out. Good question.
And is it only for the overlapping sides?
Yes. Because obviously this 15 here was already given to you. Didn't have to add it to nothing. All right, and then you got to go above and beyond. You got to cross multiply. This way gives me 20x. This way gives me 4 times 5, 60. Do that first. Crisscross multiply first. And then stop. There's my equation right there. Some people are trying to crisscross multiply and divide all in one step. And I've been seeing so much confusion. They're like, ooh, I'm timesing and then I'm dividing at the same time. I'm like, what? Don't do that. Get your equation first. One way, 20 times x, 20x. Equal. The other way, 4 times 15, 60. There we go, I got my equation. Check. Now I'm ready to show an inverse operation. Now, do the opposite of timing by 20 divide. But don't divide while you're cross multiplying. Cross multiply first. Get that equation first. And then divide. And then hopefully you're seeing With that being 3, that matches up perfect. 4 times 5, the entire bottom length, 20. 3 times 5, 15, 15. 7 times 5, the entire piece, 35. Hopefully. Question? All right, and then the last one's, of course, the recognition. This one is a angle, side, angle, sandwich. That is pure congruent yumminess. Yummy sandwiches are good. Yeah, math, yummy. Another sandwich, because I'm hungry right here. Ooh, another side angle, side sandwich. I'm always looking for those sandwich ones first, because this time of day I'm hungry and I want to find those sandwich ones. Those are the easy ones. But then the tougher ones are the angle, angle, angle one. That is not similar or congruent. I could put the little similar symbol, but can't put the full-fledged congruent symbol. And then the hard one that crushes people, this one, the double AS or the SAA or the ass one. Ass is bad. People look at that and they think it's angle, side angle, but it's not. And then for this one, which I kind of jumped the gun, so I didn't erase this. We're giving you the theorem in 2 parts and wanting you to put another part to make it match that. So for this, if I'm telling you this is ASS and I give you an angle and a side, we want you to put a mark on there to make it S. So you would not put the mark right here because that would be side, angle, side. Nope, don't put it there. You don't want to put a little angle mark right here because that would be angle, side, angle. Nope, I want it to look like F. So I got to know where to put that. It's got to be right. That mark right there makes it S. Any other mark makes it side, angle, side, or maybe angle, side, angle, or something altogether different. So I had to put the mark right here exactly. All right, I'm going to give you about 10 minutes here, 15 minutes to just put on your slide that copied one and try to get as much done as you can in this 15 minutes. Just know that no matter what you say, I'm going to give you full credit. Most people last period were able to get a picture of some kind of work on their slides. My people who are in class in front of me, I'm going to have them put their work on the document camera for you people to see, so you'll be able to see their work on paper. But no matter what, I'd like you to try the next set either on paper and put a picture of that work on your slide, or do the work on the slide itself, because you can use the Google Slides software to do some of this work. All right, questions out there? Anybody? Can you still hear me out there?
Where do you find that slide?
That slide is slide 53. It's on the master document. Do you know how to get to the master document?
No.
Okay, then your grade's probably hurting right now because everything's on there. So I'm going to put it in the chat. So just know that you need to get to this document to have a chance to pass, and you have to have a Google slide shared with me for you to have a chance of passing this class this quarter. So I'm not sure who I'm talking to, but at this point, if you're asking me how to get to this, you are falling way behind the class, dude. I showed you how to get to this the very first day of 4th quarter. So you're technically falling behind if you've never been to that document. Or also, if you don't have your file shared with me, your Google slide, you are in the no chance of passing zone. You need to share with me a Google slide by last name, first name, period, for a new one. Not the old one, a new one. Can be done. If these people could do it, you could do it. All right, questions out there? All right, I'm disabling the chat, so if you want to talk, you got to talk to me. And then I'll try my best to help you out in any way. Let me get this going. And then let me help people in my class here in a second. Can I help anyone out there in front of me or in Zoom land? Help anybody? If you're done quick, maybe and you're waiting, if you don't want to put your paper on the document camera, maybe you could put a picture on your slides or something. You finished already? Just know the more work you get on your slides, the more permanent, like, kind of portfolio that you have. So if you're sitting there doing nothing, either help like someone next to you, or keep that picture on your slide. Or better yet, maybe Michaela, if you can help Gabriel over there, or maybe Michaela, if you could rely on Michaela to check on Gabriel, maybe. Well, I got that from this X and this Y. So you got 18 and 24, so you're going to be doing this over 6. You know why that works here, one? There's going to be a this over this, and you stay consistent all over this. You know, I always have calculators for you. Don't expect like arithmetic, like timesing. Never have you do that stuff by hand. You don't want to make mistakes. Some people do all this beautiful work like you, and then they crisscross multiply and jack up the times. So if it's ever arithmetic, positive, negative numbers, timesing, you'll always have a calculator. Yeah, so you guys, if you need calculators, they're up here for you. This ain't no first grade arithmetic class. So I'm not teaching you your arithmetic. I'm not really teaching you your positive, negative numbers either. So if you're struggling with any of that, the tools your calculator for you to use, rather you not use a cell phone calculator. And then just know you shouldn't be able to miss any positive, negative problems. And also for you people, I have rulers ever, these little straight edges, and then compasses is if we ever get back to instruction. What's up, dude?
Is it very things on phone?
Yeah, sure. This is good, but oh, you're awesome.
I was going to do this way.
Nice. That's right. These are the fast ones, right? These are the best. This one, yeah, this is the fast one. This. Yeah, both these are side by side. Both these are sets together. But yeah, both these are side angle side. Both these angle side angle. But yeah, both these are half. Yeah, this is the last one. Good job. And then, would you know how to keep going on that one? I have calculators for you. You don't want to do this 6 times 12. I can make that calculator for you. Always welcome to do. So yeah, just how about write the equation first before you start dividing. So one way perfect would be 18, and then you're like me, I don't know what those other numbers are off the top of my head. So if I can do 6 times 12, that is 17. Yeah.
Oh, and remember I wrote that.
So one way you had a perfect 18x, start with that.
17.
Because that's what you got by attacking this way first.
I put 72 right there, but it's stuck. I'm just stuck.
That'll be perfect. And then right equal. And then now you're 72. Don't divide it. Don't erase this. You're jumping the gun. You're dividing before you write the equation. Don't want to do it. Perfect. So at that point, you have this equation. By timing this way. Now you divide. Yeah, now I want you to take a little pause right there, take a look. Because sometimes these are going to be harder. Now let's start it. All right, another minute or two before we get this started. Technically, you in Zoomland, once you talk with me and earn your attendance and your points, your day with me is done. Technically. So what is this right here? So where are you putting the angle? Yeah, that's probably because if you put it right here, right there, that's 2 angles in a row and a side. If you put it right here, that turns into an angle side angle. If you put a line anywhere else, then it's not. That's it. And then what we need to do is instead of one little mark, the 1 slash are these 2. This one maybe do. This technically, if you just draw one little arc, that shows all of these are really equal. But I need to show that these pairs are equal, but then these 2 are equal. So I'll put that into the right spot. So smart. All right, let's get this week done. So I can maybe talk grades with some people. All right, if people are with me live, I'm going to have them put it on the document camera. I'm going to do it all in one batch. So I'm going to have the people in Zoomland go first. Actually, you know what? Let's look at the people in class first, and then we'll look at the Zoomland people. Look at your slides. Remember, I'm doing this for attendance purposes too. So make sure when I call on you, you answer, because if not, I don't know you're really here. Can you see my screen right here? Anybody?
I mean, so.
All right. Volunteers out here, because I'm going to have all you people go first. All right. I'm going to have Josh go first. Can you see Josh's work right there?
Yeah.
All right, you guys are lucky. You did excellent work. Josh, can you just tell me real quick what you did for this triangle one here?
for the
middle one?
triangle one, I added 12 and 6. Oh, well, the first thing I did was I added 12 and 6 and 16 and 8 to get 24 and 18.
Good job to get the big hypotenuse and the base height.
And then I put x over 6 for the small triangle and 12 over 18 for the big triangle.
Beautiful. And what I'm going to do, because obviously you know what you're doing, can you give me another ratio that would work?
Another one. So we could do x over 8.
Yep.
And then 12 over 6, or 12 over 24.
There you go. Good job, Josh. Excellent work. All right. Next. All right, Lee. Okay, can you tell us about this first one right here, the line transformation one? This is Michaela.
So pretty much when I was drawing it, I drew the first one, GX, and then for the second one, I just went up 3 on the y-axis.
Yep.
And then drew that line, and the slope was down 1 over 2 for both of them. And yeah.
And you wrote the y. How'd you get this y-intercept of 4 right there? That's perfect.
Because for GX it was +1, and then it was also +3 for FX, so then I just added them together to get +1.
Good job. Yep. So either seeing that, putting that in there, 1 + 3 gives you the new y-intercept. Slope stays the same. Or by starting here and moving the new one up 3 boxes, and then rewriting it with that y-intercept. Good job, lady. That's good stuff. I hope you guys saw that. All right. Ready? And then just remember out there, anything you say today will get you full credit as long as you're talking. All right, Elia, can you just tell me and tell us about your triangle ones, your theorems up here?
The first one is SAS.
Beautiful.
2 sides.
Yep.
And then the second one, I'm pretty sure is ASA.
Yes, ma'am.
Because it's sandwich.
Yep.
And then the third one, which is SSS.
Money. Good job. This is a tough one.
And that one, I'm pretty sure, is SAS.
Ooh, see, this is the one that gets people, because if I really wanted this to be SAS, I would have had that angle clearly between the 2 sides. But see, since the angle is not between the 2 sides, this is a pure SS in the row A. This is the ass one. That's the neither one. It's tricky. You got it. It's got one little tiny detail. Good job, Michaela. That's nice word. Full credit. Ready? Anything you say, full credit. I'll always help you. All right, we got Gabriel. Gabriel, can you just tell us about your little triangles? How you label these? That looks good, Gabriel. Like, what did you call this first set right here? Or, Gabriel, what are those 3 letters right there?
ASA.
Well, that's not ASA.
Can't even see that good.
Do you need to move closer or further?
Yeah.
Alright, move closer. Alright. How did you, for this one, what did you call this one right here, this set?
Third one?
This one right here. What did you write? Or,
I can't even see, it's so light.
this is SAS. Do you have glasses?
Yeah. No.
We have a program here that gives you free glasses. So I'd hate for you to have your education kept from you by you not being able to see. So for me, you can move your body physically closer or further depending on your sight. And then we have a program here at school that gives you free glasses. So if you're in class and you can't see, go to the office and say, man, I demand my free glasses to see my education.
Yeah, because I have to like squint for like.
Yeah, that sucks, dude. You don't want to be squinting all day. We have free glasses, dude. Because that will end up making your vision worse. Alright, so let's just, you're done real quick. This is SAS right here, Gabriel. Do you see the parts that make this SAS?
So one of the. in the middle with this side, and that one's an angle.
Yeah, this middle one's the angle, right?
Mhm.
And then on either side of it, you have the two.
Angle. Or side.
No, you got the angle in the middle.
I got the two sides.
Yep, the two sides on either side. Good job, you. You've done your part. All right, do this. All right, this is 1-1. Get this bottom one perfect. 1. For this little mark that you put, why did you put that mark right there, Juan?
So you can use the wood.
Ooh. Are these similar?
Oh, no.
The only thing that's similar is AAA, and you gotta be careful because this one right here, this is not AAA. This is pure side. If I wanted you to have this be AAA, I would have had 3 of these little angle marks on the inside. But yeah, this is side. You never fall for that trap. You see how these are the side marks right here?
I get them up.
Yeah, that should be easy fix on test day. Don't ever make that mistake. Yeah, side. But then right here, these are congruent. You did angle, side. You put it right here to keep those 2 angles in a row from that side. And when I come over and asked you one, I said, why didn't you put the angle right here? And you told me because if you put it there, that would have showed angle, side, angle, and I didn't want that. So you put it in the right spot right here. Angle, side. And also I talked about how you don't want to put no little line mark right here. But if you did like a little slash line, that would show side, angle, side. You don't want that. All right, good job, Juan. Okay, that's all the people in class. Let's do... Juan, are you period 4?
Yeah.
Yes. All right, you're a Zoom people. Are you ready? Let's get this done. Victor, are you out there, Victor? All right, this is for attendance purposes. Victor, not here. Travis, are you here today? All right, Marky absent this time. Oh, good. I'm taking a roll right now. Ooh, that was close. Can you tell us what you did on this slide, Travis? How about you pick one? Pick one, because we look at all of them already. Pick one.
Triangles.
Okay. Yeah.
Second one to the right is the bottom one.
Did you gotta remember though? Make sure you put that congruent symbol on there to get full credit, right? Test day, don't forget that symbol because even though you're listing these perfect, you wouldn't get full credit because you're not indicating to me that they're congruent. Write that little symbol on there. Good job. Good job. All right, Travis is done. Nick, are you out there, Nick? All right, Nick. Do you have anything on your slide? Can you just tell us out loud what you did?
No, I did the triangles.
You did the triangle ones?
Yeah, the top of those are triangles then.
Okay. Can you tell us what you got?
Top left.
Yeah. Do you know the congruent symbol that we use?
Yeah.
What is it?
It's equals to one with a squiggly line on top of it.
Nicely done. Good job, done. And you guys did. Good job, Nick. Have a good weekend. Callie, are you out there? Jose Reynoso, are you out there? All right, I'm doing this for attendance purposes and points. Liliana, are you out there? Jose M, are you out there? All right, Jose didn't want to be marked absent. Okay, can you tell us about your first one that you did, that transformation one? Nice. Beautiful. Let me ask you this. For those two, Jose, the first one, the G line, is that the starting line, the pre-image, or after the move, the image? The way I have this set up, that G of X line, is that the pre-image or the image? You sure? Yeah, because remember yesterday, I had f of x listed first, made it the pre-image, and you plugged it into g of x. But today, because you're smart, I flipped it around. I made the g of x one be the one you're plugging in. The g of x one is the starting one, the pre-image, and then the f of x one is the image. Does that kind of make sense, Jose? All right, I know you can. I know you understand that, Jose. You're smart. All right, Julian, are you out there, Julian? That's good work, Jose. Angelica, are you out there?
Yeah.
All right, Angelica. Can you tell us a problem of your choice? Pick one. Any problem. Good job. Nice work, lady. We can see your work. The first one, the new one got moved up 3 boxes. 1, 2, 3, right here. Doesn't mean the new one's y-intercept is 3. It just means it got moved up 3 to get the new y-intercept of eyeball map 4 or algebra map. Good job, Angelica, for showing that. That's beautiful work, lady. Alex Martinez, are you out there? Mick, are you out there, Mick? All right, Mick. I like your goats again. I like goats. Can you just tell us anything that you did maybe on paper, Mick?
I did triangle.
Okay, can you tell us what you listed? Nice. Good job. Yeah, if you call that SAS, I got you. That's for sure SSA or the ass one, the bad one. All right, good job, Mick. You have a good, safe weekend, all right? Kenya, are you out there? Can you explain something maybe that you did on paper? Yeah. Did you, for that bottom one, did you put a mark on those triangles? All right. How do you know that you put the mark in the right place? That looks perfect. Beautiful. And then just one little super technical detail. For that one, Kenya, the other angle on that little blue part, you would technically have to draw a little like double arc. Does that make sense? Because if you just drew just one arc like you did, you're showing us that all 4 of those angles are equal, and that's not really true. Does that make sense? Yeah, but that's beautiful. You'd have to technically in that blue angle, just do a little double arc that shows those blue angles are separate equal ones. Good job, lady. Nice. All right, Andrew, are you out there, Andrew? Yeah, look at all that work you've done, Andrew. Beautiful. All right, can you tell us a problem of your choice? Right. Okay. How about this? You obviously know what you're doing. For the middle one, can you give me a different ratio that works, Andrew, to show us how you could write a different set of fractions maybe to get that same answer full? So could you mix it up? Can you, instead of going x over 6, can you set it up 8 over x? Can you do it that way? So if you did 8 over x, what would the other fraction have to be? It wouldn't be 12 over... I think if you did 8 over x for the red one, you'd have to set up the big one as 24 over 12. Does that kind of make sense? Yeah. All right. Good job. Dan Garcia, are you out there? Ooh, where's your slide? Have you shared a slide with me, Dan? All right. I'm just going to go what I have here, and then I'll get back to you. Cal, are you out there?
Yeah.
All right, Cal, can you just quickly talk about something that you did? All right, that's super beautiful, Cal, but when I'm looking at your work, those answers down at the bottom, there's something crucial missing. Can you tell me what you missed at the bottom of that problem there? Where you have g of x equals negative 1/2 plus 4. The other one says negative 1/2 plus 1. You see what you missed right there, Cal?
Yeah, I see what I missed.
If you look at the top one, the g of x one,
Yeah.
that's equal to negative 1/2 what? Negative 1/2.
Over 2.
And then, yeah, you missed the x, dude. That's the only thing. I'll keep you from your A+. Don't forget to put that x in there, Cal. Nice. Have a safe weekend. Josh, real quick. Are you out there, Josh?
Yeah.
Wait, no, you already went. All right, here it is, Dan. Can you tell us something, Dan, that you did?
Yeah, for triangle split in half.
Okay.
I did x equals 6, then 12 out of 18 because the bottom line is equals to 18 and 12 over 6. Then we cross multiply about 18x equals 72, and divide each side by 18, and you left with 4.
Can you give me another ratio that would still give me 4 for that one?
12 over 24 and
Would equal.
yeah. I'm not sure what else.
So if you're doing the side of the big one 12 over the hypotenuse of the big one 24, keep it equal. Make it equal to the side of the little over the base of the little. I'm sorry, the side of the little over the hypotenuse of the little. If you're doing 12 over 24, that would have to be x over 8. Do you see that?
Yeah.
Yeah, so 12 over 24 would have looked magic as long as you kept it consistent and set that up as x over 6. All right, good job, Dan. Thanks for listening. Have a safe weekend, and thanks for being in my class. Michaela went in front of me. Leslie, are you out there?
Yeah.
Can you just tell us something real quick what you did? All right, sorry about that, Leslie. All right, Leslie, you've done enough. I see your work looks beautiful. Time constraints, we're going to move on. Have a safe weekend, Leslie. Good job, lady. All right, Buck, you out there?
Yeah.
Can you just tell us real quick what you did right here?
Sure, from the first one, SRS, it's congruent, it's congruent.
Nice job, Buck. Have a safe weekend. Aliyah went in class. Owen, are you out there? Mike, are you out there? All right, Mike. Can you tell us about one of your problems on here that you did? Okay. What'd you do? Okay. And Mike, hold on, Mike. You hear me? You did perfect. Do you know the congruent symbol? All right, you show me enough, Mike. Good job, dude. Good job. You're welcome. Lainey, are you out there? It's getting a little close on time here. Lainey, are you out there? Can you tell us something real quick about a problem of your choice? Okay. And it looks like that first one you labeled ASS, top left, but that's really SAS. You got to watch out for that one. Yeah, that one has an angle between two sides. You're doing good, though. Your work looks good. Good job, Lainey. That's full credit. All right. We're running out of time. Gio, you out there, Gio? All right. Can you tell me about anything that we went over today?
You're talking about
Yeah, congruent triangles, yeah. Good job. I like it, Gio. Who else out there hasn't talked to me afraid of being marked absent or getting a 0 or having to do a flip grid if you worry about your grade? This.
Yeah.
Liliana. I think I called on you earlier. Where were you? Liliana, are you here? All right, can you tell us something that you did on your slide? Okay, what did you write? Good job, lady. All right, last call. Who out there hasn't talked to me? Who's really here? Who am I missing? All right. So again, you're choosing to mark yourself absent, and then some of you, your grades, since you can make up everything, you're choosing pretty much your own grade right now too. All right, anyone in Zoom land, any questions for me before I log off and let these people live in front of me go? Questions out there? All right, be safe out there, make good decisions. Yeah. Big What work did you do today, Victor? Are you here?
Yeah, Victor, it's good.